Uh, Good morning to everyone. My name is Liu Qi, and this my teammate he is Tan Sim. So today we are going to talk about PNP bipolar junction transistor. We will walk you through what is it and how is the internal structure works, and most important is how to build it correctly so it operates as an amplifier or a switch. So let's start with the basic. What actually is the BJT? Its cousin, the MPN, is a three-terminal device used to amplify current or switch signals. It is current control, meaning a very small current or switch signal. That at the best, they can control a much large current flowing through the device. So let's look inside the device. The BJT have three specific regions. First is emitter. It's the most heavily doped region because the job is to inject charge carrier, in our case hole, into the base. And next is the base. It is the middle section, and it is extremely thin and highly doped region to allow the hole to pass through easily. And the last is collector. This is the largest region designed to collect the charge carrier and handle the heat dissipation. So usually you can think of PNP transistor as we have a thin piece of N-type material positioned between two rods of P-type material. Now look at the symbol on the screen. This is the most common place where people make mistake. A PNP transistor, the arrow on the emitter always point inward. A simple trick that we can use to remember is pointing and PNP. This arrow tell us that the direction of conventional current which is in a PNP device flow into the emitter. That's all for my part. My partner Tadisin will continue for the following part.
Okay, thank you for my teammate Yong Qingyu. So I'm going to introduce the next part, which is the operation of PNP BJT. So look at the first mode first. And the first mode which I will introduce, which is the forward active mode, which is known as the transistor is on. So how do we know that the transistor is on? It must have the two conditions, which look at first condition first. The emitter base, the EB junction, is forward bias, which is known as the VEB must be exceed the minimum diode voltage. 0.7 V is for silicon diode, and the P-type emitter is connected to a higher potential than the N-type base. This pushes the hole, which is the majority carrier in the PNP BJT, from the emitter into the base. The next condition, which is the collector base, the CB junction is reverse bias, and the VCB is negative. The P-type collector is connected to a lower potential than the N-type base. This creates a very strong electric field that attracts the hole that have crossed the base, sweeping them into the collector. So the next mode, which is known as a cutoff mode, and is known as the transistor is off, or known as reverse bias. In this mode, the transistor operates as an open switch, which is no current flow through it, and there's very little to no current flow. A very little, which is known as the leakage current, but it's very small, so we can ignore it. So let's look at its biasing. The emitter base EB junction is reverse bias. The N-type base is at a higher potential than the P-type emitter, preventing the hole from flowing from the emitter into the base. And the second condition, the collector base is also known as reverse bias for the cutoff mode. The N-type base is at a higher potential than the P-type collector. So this is the graph for the NPN BJT is in the forward active mode, which is known as forward bias, forward and also reverse bias. You can see that BC is reverse and also the BE is forward bias. Okay, so this graph just introduced the characteristic of the PNP BJT when we apply a voltage into it and how the current is onto it. So look at the first region is the saturation region. So this is the region when we apply a voltage smaller than its V diode. For example, the minimum V diode for the silicon is 0.7. So below the 0.7, it should be act like this. So, and the next, after we reach the 0.7 volt, and the current will become a very constant. Wherever we apply a large voltage, but it still can be changed if we apply a very large voltage onto it, which is you can see in the third region, which is the breakdown region. But the breakdown region is harmful for the diode. Like it may causes the damage to the diode. Okay, so let's look at let's look at the PNP BJT in our daily life. So the first is the radio amplifier, and also the headlight on the car, and also the wiper on the car. It's all using the PNP BJT to function on this thing. So in conclusion, a PNP BJT is a very important electronic component in wherever in the industry or in our daily life. So all our electronic things can be function as well. Okay, that's all. Thank you for your watching. We will see you. Bye.